Welcome to my channel. If you learn from this video, then like and share this video and don't forget to subscribe to my channel. In this video, we are going to learn how to convert a gray code into a binary. So let's start. So in this video, we are going to first see the exor truth table, which is required to generate a conversion logic. Then after understanding the conversion logic, we will develop the logic circuit for gray code to binary circuit, and then we will see gray code for 0 to 15 numbers. So let's start. So starting with exor truth table, I have explained the exor truth table in binary to gray code conversion as well, but if you haven't seen that video, then let's revise once again. So for exor truth table, we will require two inputs A and B, and there will be the output Y. Since there are two inputs, the options of having different inputs are 4, that is 2 square. So 0 0 0 1 1 0 1 1. So these are the 4 possible inputs for two inputs. Now as per the exor logic, if both the inputs are high or both the inputs are low, then the output will be 0. Here both the inputs are low, so output will be 0. If one is high, other is low, the output will be 1. One high, other low, output 1. If both are high, then output will be 0. So this is the logic of exor truth table. So you have to remember or understand the logic of the exor truth table because it is required in gray to binary and binary to gray code conversion. Now moving to the conversion logic. So I have kept exor truth table on the right hand side for the reference. Now we will see the exor gray to binary logic. So let's start. Suppose we have the gray code 0 1 1 1. So this is the gray code and we have to convert it into binary. Before starting, let's label it G3, G2, G1 and G0. So we have labeled it. Now we have to convert it into binary. So we'll start from MSB, that is the most significant bit, the bit which is to the left hand side. So this G3 will then I will write over here B3, B2, B1 and B0. So this G3 will be written as it is in the place of B3. So if there is 0, we will write here 0. So B3 will be 0. Now moving to B2. For B2, what we are going to do is we are going to take exor of G2 and B3. So for the next bit, what we have to do is take this G2 element and exor it with B3. So what we will get if we exor 0 XOR 1? So what will be the output for the 0 XOR 1? The output will be 1. So B2 will be 1. Now for B1 take G1 and take previous B2. That is 1 XOR 1. We will get 1 XOR 1 0. For B0, what we will take G0 and the B1, that is the previous binary bit. So 1 XOR 0 will be 1. So what will be the binary output? 0 1 0 1. So this is the binary, right? 0 1 0 1. And if you convert it into decimal, it will be the 5. So for the 5, we have the binary 0 1 0 1 and the gray code is 0 1 1 1 1. 0 3 times 1. So what we understood is that B3 is equal to the G3. For B2, what we will do is we will take the current G2, that is for the B2 we will take G2 and the previous binary bit, that is G2 XOR B3. Then for the B1, what we will do is take G1 XOR previous binary bit, that is B2. And for B0, we will take G0 XOR previous binary bit, that is B1. So let the number be 4 bit or 3 bit. What the logic we have to implement is the MSB of the B3, that is binary bit, will be same as the MSB of the gray code, and then for the next bit we will take the current gray code bit and the previous binary bit and we will XOR it. So let be any number of bits, we have to use the same logic. Start from MSB and then move one by one ahead. So this is the conversion logic which we have to remember for gray to binary conversion. So now let's create the logic circuit. So I have written the conversion logic to the right hand side for the reference. Now we will create the logic circuit. So whatever is on the left hand side of the equal to is the output and whatever to the right hand side of the equal to is the input. So let's first write down G3, then G2, G1, G0. Basically these are my inputs. Now understand. So B3 will be as equal to B3. So this is my B3. Now if you see for B2 we need B3 and the G2. So this is the G2. Okay. And I have to XOR it with B3. Then I will get B2. Right. Now if you see for B1 I will need B2 and G1. So this is the G1, this the output, that is this output B2, this is the B2. Again I will take it, this is my B1. For B0 we will require G0, B1, XOR it, we will get B0. So this is how the logic circuit is created using the conversion formula. So see, B3 is equal to G3. Then for B2 I have taken this B3, XORed it with G2, then I got the B2. So from B2 I took the B2, XORed it with G1, I got the B1, and for B0 I took the G2 and the B1 and I got the B0. You don't have to remember the logic circuit, just understand the conversion logic and you create on your own the logic circuit for the gray to binary conversion. Don't remember the how many number of XOR gates are required, how to pass from where to start the line, where to end the line. Don't remember anything, just remember the conversion logic and you will be able to create the logic circuit. So this was the logic circuit. Now we will see the different gray codes for 0 to 9. So I have given all the decimal number, it's binary conversion, that is binary form, and for that binary form the gray code is given to the right hand side. So this is for gray code for 0 to 9. This is a gray code for 10 to 50. So thanks for watching this video. If you have any doubts you can ask me in comment section. And don't forget to subscribe to my channel.